I am Mrs. K. Anbuselvi, Associate Professor of Computer Science, V.V. Vanniyaperumal College for Women, Virudhunagar. In this video, we are going to learn about construction of minimum spanning tree by using the method Kruskal's, which implements greedy strategy. Before going to learn about the Kruskal's method, we will see about what is a spanning tree. A spanning tree for the given connected, weighted, undirected graph G is a connected subgraph which has same vertices as in G, and it is also a tree. The spanning tree T of V, F for the graph G has same number of vertices, capital letter V as in G, and it contains a set of edges, capital letter F, which is the subset of E. Now we will move on to the working principle of Kruskal's algorithm. In the first step, we have to create n disjoint subsets of V, one for each vertex, which contains only that vertex. In the second step, we have to inspect all the edges of the given graph G in non-decreasing order of weight. If there is a tie, the ties are broken arbitrarily. If the selected edge connects two vertices from two different disjoint sets, then the edge is added to F and the different disjoint sets are merged together. Before moving to the next step, we have to check if the newly added edge, if it form a cycle, then we can reject the edge, otherwise we can accept the edge. If all the disjoint subsets are merged together into a single subset, then the construction of minimum spanning tree by using the Kruskal's method is solved. That is, the spanning tree which contains only n-1 edges. Now we will see about the high-level algorithm for the Kruskal's procedure. Initially, the set F is treated as an null set, and then create n disjoint subsets, one for each vertex and containing only that vertex. Sort the edges in non-decreasing order of weight by using any of the sorting procedure. While the problem is not yet solved, select the next edge with least weight. If the edge connects two vertices from two different disjoint sets, merge the two different disjoint sets and add the edge to F. If all the subsets are merged together into a set, then the problem is solved. The procedure is also completed. Now we will see an example which constructs minimum spanning tree which uses the Kruskal's method by implementing greedy strategy. Here it is the given graph. It is a connected, weighted, undirected graph which contains 7 edges. Now our aim is we have to construct the minimum spanning tree by applying the Kruskal's procedure, and it contains only n-1 edges. That is, it contains only 5 edges. For this, in order to construct the minimum spanning tree, we have to identify how many number of vertices in G, and we have to create n disjoint subsets. In this example, the n is equal to 5. Therefore, we have to create 5 disjoint subsets, one for each vertex and containing only that vertex. Next, identify all the edges in G and list the edges. Here the number of edges in the given graph G, that is E, is equal to 7. Next, sort all the 7 edges in non-decreasing order based on their weights. Next step is select an edge with least weight which is not yet considered. In this example, the first edge with least weight is V1 to V2, and check whether the V1, V2 are from the two different disjoint subsets. If they are from two two disjoint sets, then merge the two different disjoint sets into a single set and add the edge to F, and also check the newly added edge doesn't form a cycle. Here the edge V1 V2 is from two different disjoint sets, so we are added this edge to T. Next, according to the previous step, select the next edge which is not yet considered. Here in this example, the next edge is V3 to V5 with weight 2, and it is also from the two different disjoint subsets. Therefore, we merge the two different disjoint subsets and then add the edge V2 to V3 into T. Next, select the next edge with least weight which is not yet considered, and it is V2 to V3 with the weight 3. And it is also from the two different disjoint subsets. Therefore, we add this edge to T and then merging the two different disjoint sets into a single set. Next, select the edge that is from V1 to V3 with weight 3. But it is from the same set. Therefore, it forms a cycle. We are rejecting the edge. Next, select the least weight, the edge with least weight which is not yet considered. Here, the next edge is V3 to V4 with weight 4. It is also from the two different disjoint sets. Therefore, we are adding this edge to T and then we are merging the two different disjoint sets into a single set. Next, select the edge with least weight, that is from V4 to V5 with weight 5. But it is from the same disjoint sets. Therefore, it forms a cycle and we are rejecting the edge. Next, select the edge with least weight which is not yet considered, and it is the last edge, and it is from V2 to V4 with weight 6. But it is also from the same disjoint sets. Therefore, it forms a cycle and we are rejecting the edge. And also the given spanning tree, the constructed spanning tree which consists of the n-1 edges, that is 5 minus 1 which is equal to 4 edges. Now the problem is solved. So in the T which consists of 4 edges with total weight of 10. Now we are constructing the minimum spanning tree by applying the Kruskal's procedure which implements greedy technique. Thank you.